Alright everybody, question number 9. The hens on a farm lay either white or brown eggs. The eggs are put in the boxes of 6. Each boxes of 6. The farmer claims that the number of brown eggs in a box can be modeled by the binomial distribution. The n represents here and represents the number of the eggs in one box. And then probability we don't know yet. By inspecting the contents of 150 boxes of eggs, she obtains the following data. That means number of brown eggs is 0 brown eggs, we have 7 boxes. Okay, 1 brown eggs, we have 32 boxes, and then 2 brown eggs, 35 boxes. A. Show that this data leads to estimated value p is equal to 0.4. What is the p? Is the probability, right? The probability in brown eggs in one box. What does that mean? Brown eggs in boxes, that's 150 boxes. First of all, the probability is a fraction, right? It represents here favorable one, and then here is the all numbers, that means favorable one. What I'm looking for, brown eggs, right? Then calculate how many brown eggs, and there's 150 boxes. Okay, let's write it down, the favorable one. So here is 0 times 7 is 0. I'm not going to write down here, I will write down here. So 0. 1 egg is 32 boxes, 1 x, 32 times 1 is 32, and then 35 times 2x is 70. Do you understand where is it coming from? 35 times 2 means 70x, 70 brown eggs. 50 times 3 is 150, plus 88, plus 20, plus 6 times 0 is 0. So the all numbers is, we have 150 bucks times 6, which is equal to, and let's divide it by 6. Let's divide it by 9. It's much better. Divided by 9 is 4. Divided by 9 is 10. So what is the probability? 0.4. We show that. Okay. Stating null and alternative hypothesis, carry out an appropriate test at the 5% level to decide whether the farmer's claims can be justified. Let's write it down, the null and alternative hypothesis here. The null hypothesis is going to be the distribution is binomial. And an alternative hypothesis, of course, says not binomial. The distribution is not binomial. So how am I going to test this? By using the chi-square, right? But we have a problem over here. However, we said we have here 0 number. That means in the chi-square, we couldn't have a 0 number. What I'm going to do, I will add this. So number of brown eggs is 5 and 6 together. We have 4 boxes. Is this okay? I'm going to add also in my chi-square test, I will show it to you right now. I will add 5 and 6 number of x's. So I'm going to add them. That means we will have 1. So this is going to be like expected values, right? If this is binomial, expected values. So it's going to be here. But just let's go to our calculator and see how is it going to work. All right. Now we're in our calculator. What I'm going to do first, before I do the test statistic, wow, something happened outside anyway. I need to write it down my discrete random variables, which is number of brown eggs in one box. Maybe we have 0, we have 1, 2x, 3, 4, 5, and 6 x's, right? Maximum 6, minimum 0. What I'm going to do, my null hypothesis says this number of brown eggs can be distributed binomially. Then okay, go to the distribution binomial distribution, binomial probability distribution. My data is going to come from list. My discrete random variables come from list. 0, brown x, 1, brown x. Okay, and then from list 1, number of trials. How many eggs in one box? 6, right? Okay. What is the probability, brown egg probability in one box? 0.4. This is also okay. We need to save our data in list 2. Okay, click on it. Here is the probabilities, the number of brown eggs in one box. But our observed values, the observed values are given. So let's go to the list 2. Observed values are given for 150 bucks. Here my expected value for 1 box. What I'm going to do, I will go to the list 3, option, list 2 times what? 150. Yes. Click. And those are the probabilities for 150 boxes if this distribution is distributed binomially. Let me see the numbers. Do we have any problem? So 6, 28, blah, 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 go. And then you see it over here, 0. Chi-square test, when you test, and it cannot be 0. Actually, you remember it, my number of brown eggs is 6 is 0, right? Number of boxes was 0. What I did, I add them, 5 and 6, I add them. What I'm going to do, I will add these two. So please write it down in a piece of paper, what are those two values, because I'm going to delete this. Okay, I'm just going to delete it, and then I will here I will add them up. So this is 5.5296 plus 0.6144. Okay, now list 3 is my expected value. How about, where is my observed value? List 4. What are they? Is 7, right? And this 28, sorry, 7, 32, okay, 35, 50, 22, and 4. Now we can go to the test statistic. Go to the test and the chi-square test. Again, you can write them down. So list 3 is the expected one. List 3 expected values, and then observed value is list 4. Write it down on a piece of paper. Observed values is list 4. Goodness of fit test. We are not looking for is there any relationship or not. We are not looking for dependent or independent. We are looking at goodness of fit. Expected value list 3. Okay. Observed value list 4. Degrees of freedom. So degrees of freedom is you have 1, 2, 3, 4, 5 and 6 is together. That means 5 choices minus 1. Degrees of freedom is 4. Now let's see. Here is my probability, and then here is my chi-square test. But we are not given the critical values, right? Okay, let's go back to our work. All right, what is our p-value now? Our p-value in our calculator, it is 0.19, let's say 0.19. We can say 0.94, doesn't matter. So what is our alpha is 0.05. What does that mean? That means if this is the chi-square test, something like this. So this is, let's say, this 0.05. Our test statistic is 19, which means over here, right? Let's say 0.19, 0.194. This area stands for H, null, the null hypothesis. That means we are going to accept the null hypothesis, right? The distribution is binomial. We are going to reject the alternative hypothesis. And I'm not going to say so. Okay, and the farmer's claims can be justified. That's it. All right, let's go to the number 10.